Once we understand what we're looking for, finding a vertex for a parabola for the graph of a quadratic function is usually pretty straightforward. We're just looking for that lowest point or that highest point related to the function value. Determining that if we're not given the graph, though, or if our vertex doesn't land at a nice point where we have whole numbers for both values, it can be a little harder to determine. So we want to look at how we can calculate vertices for a quadratic function, which is again a function of the form f of x equals ax squared plus bx plus c. We can find that vertex, we can find the x-coordinate for that vertex by taking the opposite of b divided by 2a. So we just look for those corresponding coefficients in that general form of the quadratic equation, or quadratic function. And then to get our y-coordinate, we'll evaluate the function at the opposite of b over 2a, meaning we'll take whatever x value we come up with and substitute that into our function to generate the corresponding y value. In example 3, we're given the function p of x, which is negative x squared minus 4x minus 4. So here, our value for a is negative 1, our value for b is negative 4, and our value for c is also negative 4, but it's that constant term at the end. That means that to find x, our x-coordinate, we're going to find the opposite of b, so the opposite of negative 4, divided by 2 times negative 1, which will be positive 4 over negative 2, or negative 2. Now to get the y-coordinate, we'll evaluate that function at the x-coordinate that we just found. To get the opposite of negative 2 squared minus 4 times negative 2 minus 4, which will give us the opposite of negative 2 squared, which is positive 4, plus 8 minus 4, or 0. That tells us that our vertex occurs at the point negative 2, comma 0. And then in point B, part B, we're asked to identify if that point is a maximum, a minimum, and what type. We know this is a parabola, so when we find the vertex, that point is either a maximum or minimum, and to determine how we know that, we just look at our value for a. Since our value for a in this case is negative 1, and that's less than 0, that means that we have a parabola that looks something like this, not really drawn in place along the graph, but opening down. Let's actually just get rid of that coordinate axis. So we know that our parabola has to open down wherever it exists on the coordinate plane. That means that vertex, which is occurring at that peak, is an absolute maximum. So we find our vertex, look at our a value. Since it's negative, we know the graph is opening down, and we have an absolute maximum. Since this is a parabola, because we have a quadratic function, we know the domain is unrestricted. We just need to think about the range. Looking again at our quick sketch that we have here, we know that our function is opening down and will continue downward. So that function value that we found for the vertex of 0 is the highest point, it's the absolute maximum, meaning our range has to be negative infinity all the way up to our largest possible y value would be 0. So our range is negative infinity to 0. Similarly, in example 4, we want to find the x-coordinate for our vertex. That will be the opposite of negative 40 over 2 times 5, which will be positive 40 over 10, or 4. Then we'll evaluate our function m at that x coordinate that we just found. Meaning we're substituting in 4 for each iteration of x, each instance of x. So we'll have 5 times 16 minus 40 times 4 plus 3 will give us negative 77. And we know that we have a vertex at 4 comma negative 77. To determine if this is an absolute maximum or absolute minimum, we look at that a value, which in this case is greater than 0. That tells us our function is opening up, so we have an absolute minimum. Because our curve looks something like this, where our vertex is at the bottom. Since we have a quadratic function, our domain will be unrestricted, negative infinity to infinity. And our range will be that smallest function value that we can hit, which is negative 77. And our function will continue increasing in both directions, so headed off to positive infinity.